Okay, welcome to this session, and in this session let us discuss about the basics of Java swings. Fine. So it is somewhat an alternative for the Java AWT, and so we'll see how exactly it's going to be alternate for the AWT, the GUI application, what we were discussing in the previous sessions, what I was discussing about the Java and its object-oriented concepts. So now when I'm going to talk about swings, as usual, as I told you, we need to compare this with the AWT. Fine, because the swing was evolved or swing was developed so to address few issues of AWT, and that is what we bring in the swing for you whenever we're going to talk about the Java application with respect to GUI. Fine. Hence the AWT is one of the crucial part of Java program. So whenever I want the graphical interface or whenever I want the graphical user interface application, yes, I do use AWT. But the AWT is no longer widely used to create GUI. Most programmers use swing for this purpose, and that is where I talking about the swing. And that is what we need to learn about swing and the efficiency or the essentiality of a swing. And swing has more powerful and flexible GUI components as compared to AWT. This is the one thing which has made the swing to be used more widely than AWT comparatively to AWT whenever I want to create a GUI Java application. The powerfulness what we are going to bring in, or the flexibility of the GUI components what I can bring in. Hence we can say the swing is going to provide the look and feel of a modern Java GUI. Whatever the modern GUI you are seeing, this is going to be due to the swing what we are going to have in my application. Hence the origin of the swing, where exactly that has been started with. So this has been thought, or somewhere the developer has thought we need an alternate to the GUI subsystem, that is the AWT subsystem what we add in Java program. So it has some deficiency. That is what, to address the deficiency, we talked about swing. The swing was designed and the swing was deployed so that we can have the modern GUI Java application. The AWT has limited graphical interface, and the AWT is limited in its graphical interface due to many reasons. Out of that, the major reason is, so this AWT, whatever we were using or whatever we had used to create GUI, it is platform specific. It is going to depend upon the platform. If I am using Windows, I need to deal with the window management of the Windows. If it is Linux, I need to deal with the window management of a Linux. Because when I say graphical user interface, I do need a graphical window. And right now I don't have the authority to create window or to manage the window solely. Hence, I need to depend upon the platform. I need to depend upon the operating system which is giving me the window management system or allowing me to do that. Hence, the AWT was tightly bounded with the platform what we are using. Hence, due to this, there were limited graphical interface, because whatever I want to do or whatever I want to design, the window, the button, the menu, the text field, whatever I want, I was supposed to depend upon the platform. Hence, this has made me, being in AWT, to have a limited graphical components. Hence, due to this platform specific equivalents or the peer specific equivalents, the native code resources was supposed to use. Hence, whenever I want to bring in some graphical component, I need to interact is as an heavyweight threads, which is going to take lot of processing in that. Hence, the platform specific applications what I add or the platform specific AWT interface what I add. Due to this, which has led me to several problems due to the platform specific or the native PID. Hence, we had few problems with respect to whatever the graphical interface we were using. If it is going to be a platform specific or platform dependent, these are the few problems which we can look into or which we are going to encounter. The first problem is variations between the different platform or OS. Now, whatever the code I develop to manage the graphical user interface, it is going to be only for the Windows, and later on the same thing should be deployed on some other platform like Linux. It was not possible. I should do some sort of modification, some sort of code compatibility. I had to deal with all these things. Hence, the variation between the different platform or OS will create a problem for me. And the look and feel of each component was fixed. That is, whatever the look of a GUI component or the feel of a GUI component the Windows was giving me, I need to use the same. Or the Linux was giving me, I need to use the same. Hence, when I'm going to talk about the look and feel of each component, it was fixed with respect to the platform what I'm going to use. The second problem which is going to evolve if I'm going to use the native PID graphical user interface packages. And the third problem is, so use of heavyweight component causes some frustrating restrictions, because the Windows, the interaction, the Linux, the interaction what I do through my program will create a heavyweight process. In turn, I'm going to have heavyweight component, so which is going to create me some restriction rather than restriction. It is going to be frustrating restrictions. And so whenever we are going to use the AWT, which is the native PID or the system PID, the specific system configuration problems what I am going to have, the heavyweight component whatever we are going to have, so is always rectangular and opaque. That is, now if I want to create a window, now the window should be always a rectangular, and as far as it should be opaque. If I want some transparency in the window, or if I want some different kinds of structure like a triangle window or a pentagon window or some uneven structured window, I am not supposed to do this using AWT because I am tightly bounded with the platform what I am using. Now just look at this. Now by default, if I am using a heavyweight component, this is what is going to happen. Always I am going to have a rectangular window and I am going to have opaque. Now if I am going to talk about swing, if I am going to talk about a swing, now this is the window what I have created. This is the structure what I want. Now this is not a total rectangle. I can design the way I want now, and even I can bring in some transparency, not total opaque, but I can bring in some transparency. So this is what we should be able to do. When I'm using heavyweight component, I'm going to have always fixed structure. And when I talk about the swing, now I can think about some lightweight component which is going to allow me to do all these kinds of modern GUI. This is where the swing is going to come into picture over the AWT. Hence, the AWT was sufficiently serious that a better approach was needed. For all this reason, the heavyweight component and the modification or the compatibility was not so easy for us because it was tightly bounded with the platform what I am using. So for all these reasons, AWT was sufficiently serious that a better approach was needed. Due to this, in 1997, the solution was Swing. And the Swing was included as part of Java Foundation classes. That means now Swing is not an external package. It is the basic package of your Java. Once you're going to have a J2EE or a Java, basic Java, the core Java, the core Java itself will contain all the packages, required packages to develop a Swing application. That is what we are going to talk about Swing and the powerfulness of a string. And the Swing is built on AWT. So remember this word. Now when I say AWT and when I say Swing, so Swing was alternate for AWT. This doesn't mean that AWT will be scrapped and Swing will be used alone. No, that's not the case. Whatever the Swing we are going to have, it is built on the AWT. Hence, the application, the Swing application, what I'm going to have, it is going to use few components or some components from AWT. Hence, the application what has been built with AWT can also be run using the Swing application. This is what the Swing is built using the basic base of AWT. And so when I talk about Swing, it's always going to be main two key features. First key feature is the lightweight components. That is what I mentioned. If it is AWT, all the components is going to be heavyweight. But to solve that problem, we add a Swing, and obviously Swing should give me the components to be of lightweight. This is the first feature. The second feature is pluggable look and feel. That is, when I talk about modern GUI, I should be able to bring in the modern design or the modern structure into my library. That is what the look and feel I talk about. When I say pluggable look and feel, whenever I'm going to find a good structure, good design, I should be able to easily plug in those design into my Java environment in Swing application. That is what the Swing is going to give me two features, the lightweight component as well as pluggable look and feel. The two major components, remember, when you talk about a Swing. And so now if I'm going to have a lightweight component, so this means, and the reason why do we call this as lightweight component is that the very first important point is this is written entirely in Java program. So if it was AWT, which was supposed to map or supposed to work in coordination with the platform what it has been built, hence the code what I'm going to write, it's not entirely in Java. I need to write some part of application in Java and some part the code which is going to be depending upon the platform. If it is Windows, I should talk about some C# programming. If it is Linux, C programming. Hence, the entire application, J application, what I may have is not going to be in Java. Hence, just to solve the problem, we add lightweight component in form of Swing. Hence, now entire code starting from the basic scratch of the window until the any design, any component what you put on your GUI window is going to be written entirely in Java, irrespective of what platform you are going to use. Second major point, will not map directly to platform specific peers. That is what. So now there is no directly mapped with my application and the platform what I am using, which was the case in AWT. I have been totally separated this. My job is design what I want. Later on, let the platform specific deal the way it wants, but I'm saying what it should be done and how it should be handled. Rest, your operating system, the platform should help me to do this. And the next thing is window can be transparent and non-rectangular shape, as already I have been explained. So lightweight components are more efficient and flexible. It is more efficient because entirely written in Java program and directly not mapped with the platform what I am using. And it is flexible. It is going to be flexible because I can choose either to be of 100% transparent or 0% transparent, and even any shapes what I am going to have. This is what flexibility I can bring in when I talk about a lightweight components. each component will work in consistent manner across all platforms. That's the important point and the essence of Java. That is the platform independent code what we talk about. Hence, if it was AWT, this is what I was losing. This is what I was missing out. Though AWT was part of Java, so it didn't add the feature of platform independent. It was platform specific. So now I was supposed to bring the essence of the Java to say Java is now completely platform independent even with respect to GUI application. That is what the Swing is going to bring into the application with the lightweight component. Now whatever the design I do on one platform or for one platform, the same design can be used on any other platform wherever we are going to use the graphical user interface application. That is what every component now what I build will work in the same consistent manner across whatever the platform I am going to use. This is what you need to understand about the lightweight component. Fine. So now if I am going to talk about pluggable look and feel, so now this is what we call this as PLAF, that is pluggable look and feel. So Swing controls the look and feel of a component. So the complete control of this particular component or whatever the component I am going to have in the Swing application is totally controlled by the Swing itself. And the look and feel of a component is separated from the logic of the component. Now the button what you see and the logic for the button or the action for the button behind the scene will be separated. Both are not tightly bound. Both are separated. Hence I am going to have any component can be added or removed whenever I want. That is what we say pluggable. The action will remain same. So I am going to remove any input device for a radio button from the keyboard to mouse or mouse to keyboard. Hence I can play with this now. Hence I am going to have look and feel will give me this freedom where we are going to have the separated from the logic of the component. So now to use a specific style, now just need to plug in look and feel. This is what, if I want a new style of input, rather than having a push button, I want to have a rollover button. It is just remove this and plug in this. Hence we are going to have pluggable, or we just need to plug in a look and feel if I want to have a new specific style and consistent across all platform or specific platform. So I can now decide whether the design what I am making, whether this should be consistent across all platform to uphold the essence of Java programming, or I am going to have this design only for the specific platform. I can decide this. So one can design a custom look and feel. That is what the specific platform what I was talking about. Now the design of the component you can decide, you can customize, because you're totally free now. You're not dependent upon the platform what you're working in, hence you can design your own custom look and feel. And look and feel can change dynamically at a runtime. Right now I'm going to have a rectangular window as a component. Later on I may think I need a triangle window. I can do it dynamically at the runtime by just giving a drop down menu option or the way you want to do. But this is what you're going to get the advantage of using Swing. The first thing, it is going to be a lightweight component. The second thing is the look and feel. It is not only the modern GUI look and feel, but now it's going to be pluggable look and feel. It is so easy, it's going to be, and gives me a lot of freedom to play with the graphical user interface. And now just look at this. Whenever we are going to talk about this entire thing of a Swing, it can be a lightweight component or it is going to be pluggable fields. So now when you talk about a Swing, which is a graphical user interface, now this entire graphical user interface will be divided into two major things. One is the components, other is the container. So before I go for discussion of this, what exactly it's going to be, now just look at this example. I'm just going to have a window. In this window you can see lot of things what is going to happen. Fine. So now I'm just this complete window, now I'm going to call this as a frame. I'm going to call this as a frame, and whatever the content inside this window is going to be, we are going to call this as panel. We're going to call this as panel, or even this can be a container again. And inside this panel or the container, you can see some components called as label, the text field, the buttons. All these are components. Hence, the place where the components are held together, or the space which is going to be provided, the space provided and the space utilized. That is what the differentiation is going to happen. The components is the one which is going to give me the space, and the container is the one which is going to give me the space, and the component is the one which is going to make use of this space. To add the component 1, the component 2, and so on, I can add n number of components. Hence I can say container will group n number of components. And that is what I'm going to have 3 buttons here as 3 components, a label as the 4th component, the text field as the 5th component, and these 5 components have been put inside this window. Now this window becomes a container for me. And so whenever you talk about any graphical user interface window, you will be finding 2 types of components. One is the component and container. And container is also a component. It's a special type of components. That is what you need to understand by this. Hence, we are going to have these 2 types or the 2 classes when we are going to talk about graphical user interface. The component, which is independent visual controls. Button is independent, button 2 is independent, button 3 is independent, label 1, text field, all these are independent, visually available for a user and can be controlled. I can press the button, control 1, control 2, I can type the text, control 3 or so on. I can have independent visual control. And I'm going to have containers now. Now when the container is just a group of components, and again don't forget, container is also a special type of component. And so now this is what we can derive. Container is a special type of component. As I just told you, component must be held within a container itself. I cannot simply throw a component anywhere on the graphical window. Even if you throw anywhere on the graphical window is going to be a container. Hence, whatever the component, wherever you put the component in your graphical window, it is going to be within the container itself. And that is what the component will be or must be held within a container. Swing GUIs will have at least one container, because if you don't have a component, if you don't have at least one component, then the GUI itself is waste for us. It can be a label as a text or a button as an action. Whatever it is, you need to have at least one component, and to put that component you need to have at least one container. That is what the Swing GUI will have or should have, at least one container. And a container can hold other containers also. There is something like a nested container. One container will be divided into 2, something like panels, partition. This becomes the container 1 and this becomes a container 2, and these 2 containers are embedded between the frame, which is going to be the top level container. This is again what you need to understand with the container components. So now we'll see components, then later we'll come to containers. So now when I'm going to have a component, the component is going to be the top level class, and this is the class of AWT package. Remember, I told you So swing is built upon the AWT. Hence, now whatever the swing component I am going to have, just observe this J in front of the class name. So this is going to be part of, whenever you see the class name with J, it is part of swing, the swing package. Hence now this class, the swing component class, whatever I am going to use, it is directly derived by the component class of the AWT package. And further, whatever the swing components I am going to use now, starting from the label, the text field, the button, radio button, menu, drop down menu, whatever the components you talk, all those are directly inherited by the class JComponent. Hence, now this JComponent provides functionality that is common to all the components what I use, because all this inherits by the JComponent. So, and this JComponent class supports pluggable look and feel. This is not going to support pluggable look and feel, but the newly created inherited class JComponent will help me and supports me to have pluggable look and feel. And now whatever the component class I am going to have, this has been stored in the package called as javax.swing. Hence, we'll just look into the classes or the classes which is going to be under the swing components. Now all these classes, this many classes which is going to be under JComponent. So these are the subclasses of the JComponent. Now starting from JApplet, if I want a button, I am going to use the instance of the class JButton. For the checkbox, I am going to use the instance of this. And for the dialog box, editor pane, menu, panel, list, menu bar, so table, toggle button, viewport, tree, window, whatever the components you require, depending upon respective component, I am going to create the respective instance and make sure this will be visible on your graphical user interface window. And all this class is the part of the header file or the package javax.swing. And this is going to be about the components. Now let us come to container. Now when I talk about a container, again it's a special type of component. Hence, when I'm going to have a container, I'm going to have two types. One is the top level containers and next is the sub level containers. Now when I'm going to have top level containers, these are the heavyweight containers which will be directly interacting with the platform system's specific operating system. Hence, whatever the Windows system, the operating system is going to be, to that it's going to be directly connected and worked with that Windows system to have all the operations of the swing windowing system. Hence, that is what we call this as heavyweight containers. And any other container in my graphical user interface, we call this as lightweight containers. Hence, now whatever the class, the JFrame, the JApplet, JWindow, JDialog. Now all these are the subclass of the class JComponent, and that is what, though I am calling this as container, even this is a component again, and this is a special type of component what right now I am calling this as container. And this four are the top level containers. Now whenever I want to put any component, I am going to first use the frame. Without frame, I cannot even put a single component, and even I cannot have any container, further container in my application. So similarly, I am going to have JApplet, I will be having JWindow, and I will be having JDialog classes. So now if I talk about sub level, at this point I am going to have JPanel. That is what we are going to have the frame. Inside the frame, I can divide this to sub panels. The panel 1, the panel 2. The panel 1 can have a number of components. Panel 2 can have n number of components. This is what we had already seen. And now this top level component is going to derive directly from the AWT class. It's going to directly deal with the AWT class component, whereas the sub-level containers will deal with the JComponent class directly. Hence now whatever you are seeing, now this is going to be the frame. This entire window is going to be the top level container for me. Inside this top level container, I need to have a container to hold this as a component. Now this becomes a component. To hold this component, I need to have a sub-level container. Hence a container inside and another container. Hence a container can hold another container also. And so now when I'm going to talk about this top level containers, now this top level container each defines set of panes. Each top level container will define set of panes, and out of those set of panes, the root pane is the topmost pane. Whenever I'm going to have pane, now just look at this, I'm going to have n number of panes or n number of window or n number of layer on a given GUI window. Hence now each frame or each applet, each top level containers what I'm going to have, every top level container will contain set of panes, something like this. Hence out of this, the root or the topmost pane is going to be the JRoot pane. And now this JRoot pane is going to hold, being this as top level pane, it is going to contain the glass pane, the content pane and the layered pane. Now whatever the first layer of pane you are seeing, this is the glass pane, and this glass pane is going to be totally transparent. It's 100% transparent. It will be in the front of the user as an interface, as the first interface, but it will not be visible for the user. Hence now this such type of 100% transparent glass pane will be used to hold the mouse interaction, because I need to track the mouse in the entire screen or the entire frame. Hence for that I am going to have a totally transparent pane or the layer, which we call this as glass pane. So behind this pane I am going to have n number of panes. That is what we call this as layered pane. I am going to have the layer 1, I am going to have layer 2, layer 3 and so on. And so now in this each layer I can put whatever the content I want, and that is where I am going to call this as content pane. Hence whenever you're going to talk about any top level or any window, a window is going to contain the top level container. Inside this container I am going to have n number of containers and different types of containers what I am going to have in this case. And so now this glass pane is going to be the instance of the class JPanel. Whatever the glass pane I want to create, if I want to create a glass pane, I need to create the object of the class JPanel. This is going to create me a glass pane for me. And so I am going to have the layered pane. It is now whatever the layer I am going to have different types of panes what I am going to have. I am going to have this as the layered pane, and this layered pane should be the instance of the class JLayeredPane. And so now with this, now whatever the glass pane I am going to talk, and I have already just told, sits above and completely covers all the other panes. Being the first pane, it will cover all the other panes what is going to be in the GUI application. By default, it is 100% transparent. And now this layered pane is used for the Z order for the component. So to check out which component is at the front, which component is at the background, and which component is overlaying the other component or not. So to discuss all these things, to know all these things, we are going to have the layered pane, which will give me the Z order for a component. That is the depth, which is the first pane, the second pane, or the first component, second component. This will depend upon the depth, that is the z axis, and so we call this as the z order for a component. And the z value, whatever I am going to have, this will determine which component overlays the another component. That is what I am going to have in the layered pane. And so now whenever we are going to have this glass pane, the content pane and the layered pane, now whatever the layered pane I am going to have, layered pane will hold the content pane. Now whatever the content I want to put, whatever the component I want to put, I need to put it into the content pane. Enter the layered pane is going to hold the content pane. And so now with this setup, now whatever the content pane I am going to have, now this should be the object or the instance of the class JPanel. Now just observe, the glass pane is also the instance of JPanel, and the content pane is also the object of the class JPanel. But the glass pane is 100% transparent instance. The content pane is 100% opaque instance. That is 0 transparency and 100% transparency. This is what you need to understand whenever you are going to build a Swing application. And whenever you want to have any Swing application in your program, just remember of this particular packages. So depending upon what component you require in your program or in your application, I am going to choose the appropriate package, and these are the set of packages which is available. If I want to work on the events, what user is going to put the action, I am going to have javax.swing.event. And if I want pluggable look and feel basic package, I am going to use this, or the metal package or the multi-user package, I am going to use any of this, or the synchronization synthetic package, I am going to use this. And there are this set of packages. Depending upon your requirement, you can use the specific package in your application. And this is all for this session, and this is the basic for the Swing what you want to learn. In the next session, we will see with an application or an example application of a Swing. Thank you for this session.